Google Maps? Isn't it great? Whenever I'm lost in London, it always comes to my aid. But did you know that without our understanding of special relativity, our GPS systems would not be possible? Now let's go back to 1905. Albert Einstein published 4 papers that would forever go on to revolutionize our understanding of the universe. In his paper on the electrodynamics of moving bodies, he explained how time and space are related, and the phenomenon of time dilation. So what is it exactly? In essence, it states that the rate at which time passes is dependent on the speed of the traveler. How could this be? Einstein demonstrated that if the speed of light is constant in all frames of reference, then the rate at which time passes cannot be. And this, in essence, is time dilation.
To understand special relativity, we first need to understand what frames of reference are. In classical mechanics, the movement of a body is always studied within a particular frame of reference. Let's explain it with an example.
We're now on a train, and from our point of view, and more accurately the frame of reference of the train, all the passengers and objects inside are perfectly still.
If a passenger drops a ball, relative to the passenger, the ball has only negative vertical velocity. However, relative to a bystander on the platform, that is to say with the frame of reference of the Earth, the ball has a very different trajectory. It whizzes by and has both horizontal and vertical velocity.
Let's now imagine we embark on this train a clock made of 2 mirrors, A and B, one on the floor of the train, the other one on the ceiling, and of a beam of light bouncing between the two. For a person inside the train, the time taken for this beam of light to be reflected from the ceiling and reach the floor again is delta t is equal to 2L upon c, where L is the distance between the floor and the ceiling, and c is the speed of light. In contrast, a stationary observer outside the train looking at the beam of light would see the light move diagonally, traveling a greater distance. However, according to the second postulate of special relativity, the speed of light is constant. This must mean that the time taken for the light to travel from point A to B was different aboard the train than it was from the point of view of the stationary observer. The faster an object travels, the slower time passes for it. This is time dilation.
Given the 2 equations for delta t and delta t prime, we can use Pythagoras' theorem to relate c squared t prime squared equals c squared t squared plus v squared t prime squared. By rearranging and timesing by 1 over c squared over 1 over c squared, we achieve the equation t prime equals t over root 1 minus v squared over c squared. This is the equation for time dilation.
So what does all of this have to do with Google Maps? Well, our GPS systems work by artificial satellites orbiting Earth. According to special relativity, these satellites are supposed to fall behind the clocks on Earth at about 7 microseconds per day.
This is because of the high travel speeds in order to maintain their orbit around the Earth. This also indicates that time passes slower for the satellites whilst they're orbiting. Engineers have to take this into account so that they can get more accurate data while taking into account the special relativistic effects.
So next time you get lost in London and need to use Google Maps, thank good old Albert Einstein and special relativity. Physics Review.